Well, hi, good morning, and thank you for joining my shop here, and thank you for the super thanks. Today is June 23rd, and I'm a little pooped here this morning because I was up late last night capturing astronomical images because for once the sky was really nice and clear last night. No smoke, no clouds. Fantastic. So I focused on the cigar galaxy is what I captured last night. Consequently, I'm pooped here. I'm tired today. Couldn't sleep in. Cats. So, all I want to do today, I think, is play around with the signal tracer and repeat what I did some time ago. Some time ago, I traced a signal through the radio. Well, actually, I couldn't trace it through the radio. I can apply a signal to the antenna. It never appears on the grid of the first tube where it should appear. And all that stands in its way, the signal's way, are these coils. Well, now I got a much better idea of what's going on with these coils. I'm not going to suggest there aren't more surprises to come. After all, that's what a surprise is. You really can't anticipate it. But I think I've got a good enough grip. If I repeat the tracing, I may find out I just did not trace signals correctly the first time through, and perhaps that led me off into the Never Never Land I've been in for the last 4 or 5 sessions, I think. That's a lot. So, I'm going to feed a known signal into the radio antenna through here, coming from here at around 600 kilohertz. I'm going to make sure the radio is tuned to around 600 kilohertz where it is. And now we're going to trace the signal. Don't even have to turn the set on to trace the signal. Okay, we're going to use my signal tracer here. I need this to be set as a radio receiver, so it's on RF, band B, and it's tuned to around 600 to start. We have to connect a ground lead here. Simply put it on the chassis. Take this great big probe. Did I have that taped on there? So that this cap will fall off if I tip it the wrong way. That's all that is. Just this black cap. Okay. What do we get from the signal generator? Should be a moderate signal. I had this tuned right on. Okay, so we're going to give it a little more signal there because there's some kind of funny sound. This should be a lot louder. Well, what's that other stuff? What is that? So the radio's not even plugged in. It's not connected to anything else but that. Oh, that. Huh. Oh well. Just put it on the list. Okay, so comes along, follows the red wire over to the switch and appears here. You heard it. With the switch set in AM, it should appear here. You heard it. The secondary side of this coil should be carrying it. Well, there it is. But much less strong. Coming in. Going out. Let's just jump up to the grid cap on that tube. I'm just going to kind of lean over here and do it. there it is. You can hear it. Nothing. Top of the capacitor. Okay, so this lead is going to the capacitor. This should carry it. Okay, double check. Is it really there? But on the tuning capacitor, this is what you hear. Not a thing. Okay, let's turn that band switch. Never a thing. Okay, well, I feel better now. If this had worked out, well, I don't know what I would have done. I would have, well, I don't know. Keep going. That's basically it. That's all you really can do. So there really is something, and it does appear to be related to this coil. Is it just a question of tuning? Oh my God, could it be that simple? If I just filled with these capacitors are not connected to this coil, are they? He says wistfully. Yeah, I think so. I think so. Oh my gosh, is that what it could be? Come on, no. I want to get at the. I want to get at this. How can I tilt this right? Can I put it right upside down? Let's see if we can do that. It's like a little hard on the radio. It's going to sit right on top of a tube. Can't do that. Meanwhile, okay, and I'm holding the radio. I would normally stop the video at this point and solve this, but I have the radio in the air, so. Get me more blocks. I don't know if this is going to work out. I get to watch a grown man play with blocks. Can you sit there? Even it's sitting on this transformer now, which isn't so bad, but it's not getting any support here. More blocks. I need more blocks. I'm running out. Porcelain tiles. Okay, I did it. There we are. Okay, now I want to clip lead this in. I'm extending an antenna on that. That's why it's going to hear more and more of these long leads. Put it on the of course, making this connection will have disturbed that coil a little bit. So there's nothing precise in what I'm doing, but at least I think I can investigate. Now I'm going to start turning these capacitors. And I really don't know for sure what they're hooked up to and what I am discombobulating as I do it. Let me just look more closely here. Okay, I don't think there's any question. This capacitor is connected to the coil that I'm working on. Here we go. I don't hear a thing happening. Because my test is bogus, maybe? Let's move the pickup point to the grid of the first two. Wow. Wow. What happened there? I wouldn't expect connecting the white wire here would cause my signal tracer to go silent. That's interesting. Now there's also this weird oscillation thing in this radio. Let's just tune this thing around and see what happens. Turn this up. It's full blast on my tracer. Anything funny happening? The washing machine has returned. Sounds from outer space. Well, nothing really weird happened. Can you see this whole plate is moving up and down? So what's happening there is the string is getting up on top of the larger diameter area here, where it's doubling over itself. And in the course of doing that, it's shortening, pulling down. It's pulling down on the wheel, which is pulling the whole thing up. Right. So what's this telling me? What's going on now? You know, that'll eventually break this wire here in the long run because of the flexing. It'll be a long, long run. Oh my gosh. Well, tune this capacitor. Not a thing. Well, I hope I was right about the capacitor. I've just untuned something else. Oh my gosh. We're back to this coil. So a possible explanation for the situation is although the coil measures continuous, both the primary and the secondary, it could be a short in one of those two coils, effectively removing many of the turns. So instead of it being, a 100-turn coil, it's effectively a 2-turn coil because of a short circuit. Generally speaking, shorts like that don't really happen. It's hard to short out a large number of turns. You can short out a few because the turns, because of the way they wind these things. But anything can happen. How would you go about finding that out? Well, one way is to measure resistance of the coils, and then you look on the schematic and it tells you what the resistance should be. That's a tricky one because the resistances are so very low. And another problem, not directly related to this, on the circuit of this, causing the problem. I was going to say switch improperly wired, but no, we're right here. See, if you can get a signal to this point, it reaches the grid cap. It should. I think it's almost. It's a straight through connection. I put my finger on the grid cap. It should sound exactly the same as this. Doesn't sound exactly the same. There's this wire. Oh, this wire goes down here. Wait a minute. Now I got the radio on a difficult angle for me to see. I'm going to move it again. Leave it where it is. Okay, using my signal tracer because the radio is not plugged in or turned on. That's what happens if you touch the antenna. Nothing. Where's this wire going here? I had to do it by touch. It's going down. Okay, there's something really odd here because I can touch it here. The other end of the same wire touched here. There's nothing. And then from here, yeah, good chuckle there with no explanation. What are you laughing about, Jim? I'm just laughing at how crazy this situation is. Well, why would this coil be connected to a terminal on the IF? You can't see it, but behind here is the IF, the first IF. Why would that be? Why would that be? Because this terminal is actually a ground point. Well, I don't think so. I don't think so. What I think doesn't really matter. Let's find out here, because it's pretty easy to get incorrect observations or thoughts or paradigmic ideas into your head while you're doing this without really even realizing it. So I'm pretty sure I tested this for a ground and found it not to be grounded before. Let's test it again. So look at this. Listen to this. Can you hear the tone coming from the signal generator? It's very faint. The 1000 hertz tone. Well, why would hooking up an ohm meter, which is showing open circuit, by the way? I think what I'm doing is I'm adding in a huge antenna here, and it's just managing to pick up signals and convey them in the radio and just showing up in my tracer. It's really nothing more than that. It's definitely not a ground point. Well, then the other one would be a ground point, wouldn't it? No, it's not. You see? You see? You see? Do you see? I don't see. I don't see. Yeah, I want to think that the last guy just figured something out by fiddling around until he got something working good enough in his view. But I have no reason to think that. I have no reason I don't know that. I don't know that to be the case. For all I know, the last guy who worked on this was one of the best engineers in North America. And he probably was, in fact, because this was a commercial guy doing this with a commercial operation. Much more serious than what I'm doing. And by the time he did the tubes and did the sockets and did the power supply and put in the transformers, the price tag on this repair is going way, way, way high. And he better deliver a miracle. If you're going to ask for a lot of money, it better be a miracle you're delivering. The radio works perfectly. Works better than it ever worked. Although to some degree, just swapping the tubes out and making it, a radio capable to plug in the wall is a bit of a miracle right there. But from a owner, consumer, non-technical point of view, all the stories about how hard it was to go from, the original tubes to this tube and all this stuff, it would fall on deaf ears. And a guy doing this would know that. He'd also know that he's entering into a journey that is fraught with problems. Yet he did it. So my guess is the fellow who did this was a top repairer. Really experienced, not afraid to take something on like this, quite reassured he can work his way through all the pitfalls that will come. So that means I think reasonably I'm following probably one of the best, looking at this radio. The guy before me was probably one of the best guys doing this that you'd ever run into. And I'm not his match. I'm not up to it. Well, if it's a defective coil, what would we do to overcome that? Why is this wire going down here? Is that a mistake? We should look at the secondary windings on the broadcast coil transformer on that schematic and just see if there isn't a hint about how it's done. And why would the wire go down here? From there, and there's more wires. There's 3 wires on that terminal. Three wires on it. Going elsewhere in the radio. Two going elsewhere. Let's look at the schematic. Maybe some answers can be found there. I need answers. Somebody, give me an answer. Okay, now here we are. Here is the coil in question. And the primary side is nothing more than going to ground. It just doesn't get any simpler than that. Antenna through a coil right to ground, right to the chassis. Now the other side, yeah, I did look at this before. Neither side is grounded. Now look at this. There is right from here. There is a connection, wire connection, right to here. Along the way, somewhere, there's a 0.5 capacitor, probably changed out by the last guy. 0.5, that's a biggie. That's a really big one. That's a really, really big one. I don't see any really, really big ones in here. It's got 2 electrolytic jammed in there that we haven't really looked at or talked about. It's a scary thought how much more stuff could be down further in this radio from where I am now. I mean, I'm right here. I'm standing on the doorstep. I haven't even got through the front door of this radio yet. Oh my gosh. Okay, so the other way, so I'm going to have to trace these out. One wire going to the switch. So you're basically switching the tuning capacitor between this coil and this coil. That's easy enough. Yeah, I'm gonna spend some time on my own tracing through this because it's just too finagly to do it on a video, and I've done it once already and somewhat unsuccessfully. I think I'll do it on my own. And yeah, right. Okay, I'm gonna do that. Okay, so I've made that diagram. Here it is down here, and I have found some very interesting things. But again, if I got it right, I mean, there's a good chance I've got something wrong here. So you're going to watch me go through what I just did, and this is the best sort of display I can come up with for you to try to follow me. Good luck. Good luck. So let's start just looking at my own diagram here. That's the switch over here. That's the coil that is of great interest today, this one right here. These are the secondary terminals, and these are the wires running around in the radio. From there, this is one IF can. This is the other IF can. Sorry if I didn't have it on screen there while I was doing that. And I'll just get right to the meat of it. The battery, according to the schematic, is in this line. But in the radio, no, it wasn't. It was connected somewhere else. This line here is a continuous wire from here to there with nothing else connected to it except the resistor up here and this wire coming back over here. There's no parts connected to it. According to what I figured out, the battery should be in this line. There should be a capacitor here going to ground, and this resistor should be connected also to it, and this resistor is heading off to the short wave coil. Did I get all this right? Probably not. This is the volume control here. The volume control grounded end is here. And you can see that this wire coming from the coil is actually continuous all the way up to here to here. Very curious looking at this stuff. On the schematic though, it actually does make sense. If you follow on the schematic starting here, the volume control. Now how am I going to be able to do this? So the volume control, see my pointer over here, is there and above me here. I can't quite point at it, but if I could stick the pointer in. You got a mouse, Jim. Use the mouse. Use the mouse. Okay, here we are. So this is the volume control. Grounded end, business end with the audio going off. This is the other end that we're interested in. That's the other end that we're interested in. So next thing coming from the volume control on the schematic would be R4 2 megohms. I measured this at 3 megohms previously. Now, on the other side of that resistor, right here, is the battery. So the resistor should be feeding through the battery. This is just a terminal spot here. There's nothing going on. It's just where wires are connected. And this is a two-terminal. This has 2 terminals, and the center one is soldered to the chassis, but nothing's utilizing it on the terminal strip. So this is nothing more than a connection here. No sign of a battery being in here, ever being in here. How would you do it? No sign of this capacitor, no sign of this resistor. If we look, let's keep looking on the schematic there. I'm going to set this here like this. If I can I do that? Sort of. If we look on the, I can't point with a stick on my computer screen. You'll never see that. So on the other side of the battery, in the wire, let's see, where's this wire ultimately go? Just follow it along. It gets to the coil in question. So that makes sense. But along the way, it goes through a battery, finds a capacitor to ground, a big one, big honker, and another wire leading to a 100,000 ohm resistor leading to the bottom of the other coil. None of this appears to be here. None of this. This doesn't appear to be here. This isn't here. Now, earlier I gave a little bit of a speech on, who did this to this radio, and I sort of convinced myself that this had to be a very, very good radio guy who's done this. And perhaps he has so much insight that he's essentially able to recreate the front end of this radio, do his own thing. If you remember, the battery was originally connected one side to the chassis. That's not happening here. What was he trying to do? And having taken the battery out, well, maybe he was trying to use the battery to lift the bias on the tubes just as it does here. He just found a different way to do it. And this is the challenge for me, trying to get inside somebody else's head and understand what they're up to. And I really think it's a master radio repair guy, probably a lifetime of experience. I'm stunned that anybody would even try any of this, ever. It just seems completely kind of suicidal. And of course, beyond that crazy notion, changing the tubes in here, is the crazy notion that a guy like me can come along and sort all this out and get this set working again. So what are my options? Well, if I try to restore the radio as per the schematic, I'll probably run into big trouble because the fellow previous has done his own thing in this radio, and the schematic just can loosely be associated with the radio at this point, but maybe not even that. I mean, the fact that this wire is continuous in the radio but has all this other stuff on the schematic, it kind of tells me maybe what he was doing was what I had suggested some time ago. Just narrow the focus down of the radio, focus on the broadcast band, maybe even tell the people you're going to do this work on. Go, I can restore the AM side of it, but the shortwave side is never going to work again. Most people in North America would say, shortwave? What's that? So they wouldn't even care. Most people. So that would be a good story. And then you could just focus on making this thing work as an AM radio and doing all this stuff. This battery was intended for the other tubes. Having changed the tubes, the bias requirements could be different, maybe not, I don't know, but it wouldn't be dramatically different. It could be different enough that you don't need this 1.5, or you generate the bias through other techniques, because there are other techniques. Sticking a battery in the radio is not a good way to go, but he did stick the battery back in the radio. And it looked to me like it was between this post and this ground terminal down here. He had connected it. It looked original to me, but maybe not. What did I even do with it? I just put the clip down here somewhere, but I probably can't find it now. Maybe I'm remembering this wrong. Maybe it was over here? I don't think so. I think it was from here to ground. Well, this is an entirely different circuit. I haven't analyzed this, exactly what's going on here. I don't know, maybe the tubes he put in, one of them required some kind of bias support, and he stuck a battery in and utilized the bits and pieces that were in the radio already to achieve what he wanted to do. He was actually biasing one of the tubes in particular, nothing to do with what was trying to be done here. I believe too the original batteries that would have been in this radio, I'm going to show you once again, would look like this. Little button battery. I think these things run essentially forever. Well, not totally forever, but you would never have to change those batteries. Now, I could be totally wrong about that. Maybe that was another piece of the radio repair business, or good money was made changing little batteries and the like. Kind of similar to our modern computers, isn't it? Because there's a battery buried in most of our modern computers. So options here for me. Nothing is clear to me of what to do about all this. I think the more I understand about what is actually in this radio, the better chance I have of making it work. Basically taking the same approach as I imagined the previous guy took. That I'm going to make this radio work. And he no doubt he had a pretty strong notion of what he was going to do. And you can't attempt something like that blindly. You have to know a lot about these radios. That I don't think I could do that. I don't think so. Apparently he couldn't either. So lots of questions here. Not a lot of answers. Now, why wouldn't this work? Yeah, I should consider it that way. So what would be the problem with this? So coming on this line is the audio. No. Coming on this line is the audio out of the derived from the detected output of the IF. So rectified output coming here. Often you would take an AVC voltage from here and pipe it out somewhere, and guess you're going to go through the 2 megohm resistor, then pipe the AVC out, and the AVC is heading to a coil, and eventually the capacitor. Look at that. I didn't show you this part. So this is the grid cap connection on the first tube. And look at that. If you stuck a battery in here, it would lift all this, all through this coil. The switch is closed, all the way up here. So you could actually bias this too. And this is only part of the schematic I've drawn. So you don't put the battery in. So you don't add the bias when you close the switch. So well, why wouldn't it work anyway? So basically we're looking at the tuning capacitor. Where's the antenna in all this? So the antenna is hooked up to the primary of this coil. So this coil is being energized from juice in the primary. It's then pumping at this grid, and you would normally kind of ground the other side. This is not grounded here. This ground is, you shouldn't even draw it. I shouldn't have drawn it. It's just a connection here. There's nothing connected across, not grounded. Why would you want this to go all the way back here? Because you want the AVC voltage to come through. So you need to deaden this. Is this why this radio is howling? The gigantic 0.5 microfarad capacitor was left off. if I put a big capacitor here, on the far side of here, it would become the reservoir, charge reservoir for the AVC. You don't have it there. You have no charge reservoir. AVC is just really fast and could do this. Could do an oscillation. Could easily get into an oscillation. You're tuning this tuning capacitor, and when you hit the magic spot, it breaks into oscillation. The oscillating path would be through this amplifier, the output of which ultimately is working its way through these IF coils. So I think one way or another you could get an amplified signal and get some feedback going and get what we're up to. So that all makes sense. That's a scary part. Is when you put the pieces together and it makes sense, but you know you've only got half the puzzle pieces. So it makes sense considering what I know. So one way forward would be, okay, we'll throw in a capacitor here. Continue to abandon the short wave, because boy, I'll just be lucky if I can get the broadcast to work here. So we would stick in a capacitor. Now, if you stick a capacitor in here, that would basically ground the bottom of this coil. And this would make the signal, make the signal much stronger. Could make the signal. So we got to try this. You stick a capacitor right up on this terminal, which is right up here. Look, there's a capacitor right here. You know, the terminals get mixed up. Is that what happened here? The only thing on this terminal is this resistor coming and this capacitor leaving. But is this capacitor supposed to be over here? I don't know what this is yet. And I don't want to, stay away. Well, that's an interesting thing to try. We should try it. I am going to try that after some coffee. Oh, by the way, I just watched a video on coffee. Hey, thumbs up on coffee. 4 cups a day, which would be 2 standard cups, because most coffee mugs are bigger than 1 cup, right? But in that range, 4 cups of coffee a day, live longer. Yeah. Okay, I'm going to go drink some coffee, and we'll try that experiment and see what happens. This might be the simple solution I've been looking for all along. Okay, I enjoyed my few minutes of bliss where I allowed myself to think, I think maybe I have found the situation here. Let's find out for sure. Now I'm going to use this capacitance substitution box. These numbers are approximations of what capacitance is in there. It only goes up to 0.22, and there was a 0.5 on the schematic. But probably if we get to 0.22, we should be able to hear some difference. One connection is going to ground. Let me put the black one on there, just because. There's no polarity in this thing. And this will be connected as we experiment along here to this terminal up here. Very easy to do. Okay. Now, can we operate the radio safely here? Because we want to do this with the radio operating. I'm going to take off the ground that goes over to my tracer, and we're going to plug them in. Now, I haven't mentioned it lately, but I'm not plugging this right into a regular outlet. This is going through an isolation transformer. In fact, 2 of them for stupid reasons I won't go into. Yes, definitely stupid reasons. Volume down. So it's in its original state. Let's put it that way. Got the signal generator running. Still going. 600. Signal input is here. We are good to go. Volume, did I say volume down? Volume down. Here we go. Anything exploding? Nothing exploding. Let me just spot a tube here and make sure it's operating. Oh yeah. Give it some volume. Ooh, he didn't like that. Wow. You know, when my cat does that, I feed him. Okay. Now I'm gonna turn this up. On and off, but starting with 0.01. 0.01 roughly. Ooh. Well, that was interesting. We got a live one here. Let's turn it down. Oh, that's coming from my signal generator. Hey! Okay. Hey! Stand back, because I'm so happy now. I'm going to throw things. Let me turn this down. Is it really? Yes, it is. Okay. Tuning. Oh, fantastic. Okay, fantastic. Tuning. Really good. Okie dokie. Stray oscillation. Okay, we'll tune up. We're away from the signal generator. Any stray oscillation here. It's gone. Ooh. So what we heard right there is a harmonic coming out of my signal generator with the volume turned up here. Okay. Fixed. I got it. So the smart thing to do at this point, shut everything off, go enjoy my day. Because I have fought a long battle to get here. And I don't want to find out that there's another front up ahead that I have to battle my way through. Fantastic. I am really excited. Really excited here. Wow. What a journey to get to here. Okay. I really, you know what? I'm going to turn it back on. I can't stop. I'm going to hook up a regular antenna. We're going to find out what happens with a regular antenna. Or maybe the... So this radio could never have worked. That's the conclusion you can reach from this. It could never have worked. I'm going to use the loop antenna on it. Could never have worked. The poor guy. That means come on, he did all this work, and then he handed back a radio that's just limping along, and he couldn't even find the problem because he was probably... He may have even abandoned it, for all I know, and returned this to the owner saying, sorry man, but you owe me $350 for what I did, but it doesn't work. That would not be a good story for anybody, would it? So put this on the antenna here. Okay, turn it up. It's good. Come on, right in here. Come on, man. Okay. Never mind the clicking sound. That's interference in my house. Come over here. Oh, I'm too excited. I'm so excited. This is the great thing to do in this kind of work. Fight, and then all of a sudden you win. Okay. Let's tune this guy. I heard the radio station.
A little bit about base position. Was playing well in Santiago Esperanza down there. It was also, viewed as maybe this isn't an everyday thing. It's some flexibility, it's some depth thing. With Merrifield running with the second base / left field job to the degree he has, having a how big of a surprise is just how good Witt's been to this Blue Jays team? Because it really did seem like they picked him up as a veteran depth add, not a guy who was going to be an everyday player at a near all-star level last year.
Well, okay. I'm on my way to having a great day because this has been weighing heavy on me the last few days. It's really been disturbing me. But once again, persistence has paid off. Even though I spent a huge amount of time barking up the wrong tree, eventually somehow I jumped between limbs, got on the right tree, and bingo. Very exciting stuff. So thanks a lot for watching. Tomorrow we'll get back to actually trying to get this radio out of here. It's kind of how it is. So once again, thanks a lot. I'm too excited. I gotta go. I hope you feel my excitement. So thanks a lot for watching, and thanks for the super thanks too. See ya.